all the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the Parade of Planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The 2 probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space, then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom, we've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker, like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole, or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole. Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was all right did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, Spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
The two Voyager spacecraft have had a great track record. They took photos of such planets as Jupiter, Saturn, and Neptune, and then just kept going, beyond the outer edge of the solar system. At the moment, Voyager 1 is more than 15 billion miles away from our planet, and is still transmitting. Surprisingly, it takes only 22 hours for the signal to travel from the spacecraft to Earth. But how is it even possible to send signals for such unimaginable distances, considering that the satellite's processor is weaker than the processor from car keys? Both Voyager spacecraft use 23-watt radios. This is higher than the 3 watts a regular phone uses, but it's still considered to be a low-power transmitter. Interestingly, because of the ginormous distance, the phone's 3-watt signal, traveling around 100 miles on Earth, is billions of billions times more powerful than a 23-watt signal coming from Voyager. By the way, large radio stations on Earth transmit at tens of thousands of watts. This puzzle is easy to solve. The key to receiving the signal is not the power of the radio, but a combination of 3 other things. First, there must be very large antennas. Second, there must be directional antennas pointing at each other. And third, we need radio frequencies without tons of human-made interference. The antennas the Voyager space probes use are indeed very big. Have you ever seen satellite dish antennas some people have in their yards? They're typically 6 to 10 feet in diameter. Well, the Voyager spacecraft has an antenna which is 12 feet in diameter. and it transmits to large antennas on our planet. Earth antennas and the Voyager antenna are pointed right at each other. The centers for receiving signals from Voyagers located on our planet are positioned at an angle of 120 degrees to each other. This allows them to provide Voyager 1 coverage at any time of the day, no matter what Earth's position is in relation to the spacecraft. These receiving stations are situated in Australia, Deep Space Network Station in Canberra, the USA, and Spain. Let's try to figure out how communication works on Voyager 1. To do so, we need to discuss the design features of the space probe's radio reception equipment and the computer system serving it. We'll start with AASC, which stands for the Articulation and Control Relationship System. Its main purpose is to send data about Voyager's position in space and its route back to Earth. High-gain AASC antenna is always directed toward Earth to help amplify the weak signal. By the way, once it broke down, but specialists repaired it by updating the program. Voyager's signal strength keeps decreasing, causing the data rate from the spacecraft to Earth to decrease too. In 2017, for example, the probe's signal strength was many times weaker than the signal of a conventional FM receiver. Luckily, modern technology has seriously improved the sensitivity of the receiving antenna network. The increase in signal gain is achieved by capturing the signal from Voyager by a station on Earth to provide stable communication between the probe and Earth. The wave frequency should equal 2114 MHz. As for reverse communication from our planet to Voyager, it occurs when the space probe receivers are synchronized with the frequency of the uplink carrier by phase. The probe converts it into a two-way downlink carrier signal and sends it back to Earth. Not so long ago, NASA announced that Voyager 1 had started experiencing problems with determining its position in space. The data the spacecraft was sending to Earth had nothing to do with its estimated trajectory and flight speed, but specialists at NASA managed to figure out where the failure was. The AASC had started sending data through an onboard computer that had stopped working years before. It was this computer that had been corrupting the information. Once experts realized what the issue was, they commanded the AACS to resume sending data to the right computer. At the moment, Voyager 1 seems to be still traveling along its initial path, which is indirectly indicated by the stability of the radio signal emitted by the probe. Speaking of Voyager's journey, gravity assists their maneuvers. When they were launched, all the giant planets were conveniently located in a relatively narrow region of the solar system, and the spacecraft managed to visit all of them at once. Both Voyagers are carrying time capsules intended for any intelligent extraterrestrial civilization. These capsules include greetings in 55 languages, as well as different sounds and images. By the way, Voyager 2 is now over 40 years old and is the most distant human-made object. And shockingly, scientists are still fixing its software issues.
On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds. which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it. All these findings are rather disturbing. But you know, understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, you know? At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine. Imagine an asteroid so full of valuable metals that it could make every person on Earth a billionaire. Well, that's not science fiction. It's 16 Psyche, a massive metallic space rock orbiting the Sun between Mars and Jupiter. It isn't just extraordinary because of its value, estimated at $10 quintillion. That's a figure that dwarfs the global economy many times over. It also has clues about the formation of planets, especially the rocky worlds like Earth. In October 2023, NASA launched the Psyche spacecraft. This mission is to explore the cosmic treasure trove. It's supposed to arrive at the asteroid in August 2029, and astronomers hope that it will give us some insights, not just about the asteroid's glittering wealth, but also about how planets form and evolve in our solar system. But what exactly makes Psyche unique? First discovered in 1852 by an Italian astronomer, it was the 16th asteroid people identified, hence its name. It stands out among the millions of space rocks in the asteroid belt for one main reason: its metallic composition. While most asteroids are rocky or icy, Psyche seems to be made primarily of iron, nickel, and possibly even gold and other rare metals. At about 173 miles wide, it isn't the largest asteroid. It's easily dwarfed by others like Ceres, but its size is still impressive. After all, its surface area is 64,000 square miles, like that of the state of Florida. Astronomers think that between 30 and 60% of the asteroid's surface might consist of precious metals. They also think that this space rock might be the exposed core of a planetesimal. A planetesimal is basically a protoplanet, a large space body in orbit around a star, developing into a planet. And this planetesimal could have grown into a full-fledged planet if it hadn't been destroyed in some catastrophic collision billions of years ago. If this theory is correct, Psyche can give us a unique glimpse into what lies deep within terrestrial planets like Earth, where planetary cores are hidden thousands of miles beneath thick crusts and mantles. Now, remember that spacecraft that went to explore the asteroid? After embarking on its ambitious mission, the Psyche probe will travel a mind-boggling 2.2 billion miles to reach its goal. This journey will take nearly 6 years. On its way to the asteroid, the spacecraft will pass by Mars in May 2026 and use the red planet's gravity to slingshot itself deeper into space. This maneuver is called a gravity assist, and it will boost the velocity of the probe and refine its trajectory toward the asteroid. By the time it reaches its goal in August 2029, the spacecraft will be set to orbit the asteroid for at least 26 months. During this time, it will analyze its surface, figure out its composition, and attempt to unravel its history. The probe is equipped with some pretty cool tools. One of them is called a multispectral imager. This instrument will snap high-resolution images of the asteroid's surface. It's supposed to help astronomers to study its texture and composition. Then, the probe has a gamma-ray and neutron spectrometer. This instrument will measure the asteroid's chemical elements, including its metal content. A magnetometer will detect a magnetic field, if any, which could confirm Psyche's origin as a planetary core. And finally, an X-band radio system will help determine the asteroid's gravity field, which can offer insights into the asteroid's internal structure. NASA isn't sending the spacecraft to assess the value of the space rock as a mining target. Well, at least not yet. The main goal of the mission is science. Researchers hope to answer fundamental questions about how planets form and evolve. And this asteroid could help us understand what happens when molten material solidifies into a core. Another question we need to answer to is, why did it fail to become a planet? And understanding the history of the asteroid might shed light on why some celestial bodies grow into planets while others don't. While NASA's mission is purely exploratory, it has also sparked interest from the point of view of asteroid mining. With its estimated worth of $10 quintillion, Psyche could theoretically supply enough raw materials to revolutionize industries on Earth. Mining it is likely to be decades away, if it ever happens altogether, but the idea still sounds amazing. At the same time, if the asteroid's metals were somehow brought to Earth, their abundance could cause the value of precious metals like gold to plummet, and it would wreak havoc on global markets. Speaking of valuable resources, let's find out how Earth got its own gold, platinum, and other rare metals. These elements, aka highly siderophile elements, have a cosmic origin story, and it's every bit as dramatic as Psyche's. These precious metals were born in violent cosmic events billions of years ago. Many appeared in kilonovae, explosive collisions between neutron stars. These metals were then scattered across space and eventually became part of the gas and dust cloud that formed our solar system. When Earth formed, those metals sank towards its iron-rich core, but not all of them ended up deep inside the planet. Destructive collisions with rogue protoplanets like the Mars-sized Theia, which most likely helped to form the Moon, trapped some elements in Earth's mantle. Recent computer models have explained how this happened. After each major collision, Earth's surface temporarily became a magma ocean, a molten layer of rock. As metals sank through the magma, they reached a partially solid layer that slowed their descent, keeping them in the mantle instead of the core. These metals then moved closer to the surface under the influence of thermal convection. That's what made them accessible for mining billions of years later. While Psyche's metals are all over the news, space has more to offer than just gold and iron. Scientists have discovered, or rather theorized, the existence of different gemstones scattered across the cosmos, like diamonds. The thing is, diamonds are made of pure carbon, and this element is abundant in the universe. On Earth, diamonds form deep in the mantle under high pressure and temperature. In space, conditions for diamond formation can occur in surprising places. For example, nanodiamonds, which are really tiny diamonds, have been found in meteorites. Sometimes they contain gases that give us clues about the early solar system. Scientists believe that it might rain diamonds on our ice giants, Neptune and Uranus. There, high pressures compress carbon into crystalline form. Researchers have also predicted that exoplanets in other solar systems could have gemstones like rubies and sapphires, depending on their size and proximity to their stars. Even Earth's moon had its own share of cosmic minerals. Scientists have found some traces of cubic zirconia in lunar rocks. So space might hold even more treasures than we've imagined. But let's get back to the Psyche mission. It might not only reveal the whole potential of space resources, but also underline the issues we could face while dealing with them. For example, mining an asteroid would require the usage of autonomous robots, machines capable of operating in harsh space environments. Plus, we would need efficient transport systems to bring materials back to Earth or process them in orbit. We would need to make sure that mining activities wouldn't damage ecosystems or space environments. There are also legal and ethical issues, like the Outer Space Treaty of 1967. It prohibits any nation from claiming sovereignty over celestial bodies. But with private companies entering the space race, debates over ownership and resource sharing are heating up. And finally, bringing such amounts of metals to Earth could destabilize global markets. So, experts suggest that space resources might be better used in space, for building habitats, satellites, and spacecraft. But no matter whether we ever mine 16 Psyche or not, its exploration will teach us more about the early solar system and the processes that shaped our planet. As of December 1st, 2024, the probe is heading for the asteroid, following the orbit around the Sun. Its journey promises not only to deepen our knowledge of the universe, but also to redefine what's possible for humanity as we reach for the stars.
Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So, inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penny pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star surface, eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast, it got hit with so much energy that its sensors got completely overloaded. And Swift wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist anywhere else in the universe. These violent explosions on neutron stars and magnetars also play a critical role in the formation of heavy elements like gold and platinum. These elements get scattered all over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that? Time can stretch or shrink depending on where you are. Climb to the top of an extremely high mountain, and time will pass a teeny tiny bit faster than if you were down in a valley. That's all because of gravity and how it affects time. We hardly notice it in our everyday life. But for scientists and space agencies preparing to send people to the moon, these minuscule differences in time really do matter. We'll get to answer the why question a bit later. Right now, a new space race is underway. Many countries want to establish long-term bases on the moon. With humans up there, things like reliable timekeeping become crucial. The thing is, the moon doesn't operate on Earth's time. A day on the moon runs slightly faster than a day on Earth. The difference is about 56 microseconds, and it seems insignificant. But over time, even such a difference can add up, creating bigger issues. So, to keep lunar missions running smoothly and prevent things from drifting out of sync, NASA and scientists around the world are now dealing with a tricky challenge, creating an entirely new lunar timescale. NASA is supposed to start using it by 2026. It's the same year they hope to send astronauts back to the moon for the first time in 50 years. But this new timescale is not just a moon time zone. It's actually an entire system that will adjust for the moon's faster time and keep everything synchronized with Earth's time systems. Only in this case will missions be able to run smoothly. You see, on Earth our timekeeping is already surprisingly complicated. It might seem like time should be a straightforward concept, but keeping accurate time is actually a precise science, especially when you consider how much timekeeping affects our daily lives. So, to keep global time coordinated, scientists rely on something called Coordinated Universal Time, also known as UTC. This global time standard is based on ultra-precise atomic clocks that scientists place in separate locations all over the world. Atomic clocks are cool because they measure time based on the consistent vibrations of atoms, so they're super stable and accurate. This helps scientists make sure UTC is the same for everyone everywhere. These atomic clocks also take into account that time moves slightly more slowly the closer you are to the center of our planet. So, atomic clocks positioned closer to the Earth's surface tick a bit more slowly due to stronger gravitational pull. This effect, explained by Einstein's theory of relativity, happens because gravity affects time. By spreading atomic clocks across different elevations, scientists average out all the tiny time differences caused by gravity. Also, for precise timekeeping, Scientists occasionally add leap seconds to account for the small natural changes in Earth's rotation speed. It sounds pretty technical, but this process of keeping everyone on the same time helps make the modern world function. After all, precise timing is crucial for global trading, GPS navigation, and even internet communications. But time on the Moon works differently. Our natural satellite has a weaker gravitational field than Earth. That's why clocks on the Moon tick a bit faster. This difference means that lunar clocks are very likely to slowly drift away from Earth clocks if there's no correction. It can lead to big problems when astronauts need to keep in close contact with Earth or navigate around the lunar surface. NASA's solution is something called a lunar time scale. Scientists aren't going to adjust moon clocks to match Earth exactly. Instead, they want to establish a unique system that measures lunar time accurately, but is also easy to convert back to Earth time. Think of it as creating a whole new framework just for the Moon. To make this lunar time system work, NASA is cooperating with international colleagues like the European Space Agency. Together, they're setting up what they call LunaNet. This lunar network will be a bit like the Internet for the Moon. It'll make sure all the lunar clocks work together and align with Earth-based time. Just like how atomic clocks around the world coordinate for UTC on Earth, clocks on the Moon will be part of this larger LunaNet network. Now, scientists are pretty experienced when it comes to managing time in space. Global Positioning System satellites, which orbit Earth about 12,550 miles high, have atomic clocks on board. These clocks tick faster than clocks on the Earth's surface because they're quite far away from Earth's gravitational pull. But then, how does GPS navigation stay accurate? It's because scientists have figured out ways to slow those clocks down to match Earth's time. This experience with GPS clocks is a great base for what scientists need to do on the Moon. In some ways, it might be even easier than managing GPS. Scientists can work with lunar clocks as they naturally are, instead of needing to adjust them to sync perfectly with Earth. By setting up accurate lunar time from the start, scientists hope to avoid some of the complications of managing GPS satellites. And now, here's the interesting part, or maybe more interesting. To keep lunar timekeeping a reality, NASA and its partners want to set up clocks both on the lunar surface and on satellites orbiting the Moon. Some of these clocks will be long-lasting atomic clocks, and others will be crystal oscillators. Those offer stability over short time periods. Together, these clocks will create a network that scientists will be able to rely on. Meanwhile, atomic clocks for space don't come cheap. They can cost a staggering few $1,000,000 each. Luckily, crystal oscillators are more affordable, but they don't stay accurate over long periods. Once those clocks are set up, they'll work together as part of LunaNet, which will be NASA's framework for everything related to moon-based time and data networks. LunaNet will act like an internet for lunar operations. Different space agencies will contribute to it, like how internet service providers work for us on Earth. But there's another set of challenges, and it's connected with the Moon's rotation. Firstly, a day on the Moon lasts much longer than a day on our planet because it takes the Moon about 28 Earth days to make a full rotation. Plus, the Moon's equator experiences about 14 days of sunlight, followed by 14 days of darkness, unlike Earth's regular day-night cycle. And at the Moon's south pole, where NASA is going to establish future lunar missions, there are areas that stay lit or in shadow permanently. It might make it harder for astronauts to keep track of time. NASA and its partners hope to involve more countries in this project through international organizations like the International Astronomical Union. The idea is to get as many countries as possible on board with the lunar timescale, so that everyone exploring the Moon is on the same page. Now, another really exciting thing about all this is that figuring out lunar time could help other future space missions, like trips to Mars. The experience and knowledge we'll get from setting up a lunar timescale are likely to serve as a blueprint for managing time on even farther planets. That's one of the reasons why scientists are taking this lunar project so seriously. As for astronauts living on the Moon, a consistent, reliable time system will be essential, not just for navigation, but for everything from scientific experiments to day-to-day activities. NASA's Lunar Time Project is truly groundbreaking. It's the first step toward managing time as humans expand farther into space. And if they get it right, it'll mean that future astronauts won't just have Earth time to guide them. They'll also have a moon time, and even, one day, a Mars time too. Precise timekeeping matters both for the sake of scientifically understanding the passage of time on the moon and for setting up all the infrastructure necessary to carry out missions. Scientists are also eager to create a timescale from scratch because they can take everything they've learned about timekeeping on Earth and apply it to a new system on the moon. Well, I'm out of time, so bye! There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's $1 million questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri E, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri E had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Concrete E might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Concrete E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where two massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets like Korot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on. Kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know – time, space, matter – breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light-years. It would be a cube about 1,000 light-years on each side. For comparison, our Milky Way alone is 100,000 light-years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size, or radius, of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate. Right after its creation, the cosmos was shrouded in darkness. I mean, I wasn't there, but that's what most scientists are thinking. All of the stars were hidden behind a thick cloud of primordial gases. Then, all of a sudden, something cleared up this fog, and the universe started shining as it finally woke up. But how did this happen? 8 faint, recently discovered galaxies might hold the answer. The Big Bang created our world around 13.8 billion years ago. At first, it was just a super hot and chaotic boiling soup of particles. But over time, things cooled down, and particles could finally stick to each other. That's how the atoms appeared. Some helium, but mostly hydrogen, the very first element. And these first elements started creating thick gas clouds, which were very opaque. Then the first stars started forming. They were incredibly bright, emitting lots of light, including ultraviolet radiation. But even though these stars were shining, much of their light couldn't travel far because of that nasty hydrogen fog. The gas clouds absorbed and scattered any little light particles around. It was like the light was trapped around the stars. The Dark Ages lasted for hundreds of millions of years. Then, everything changed. Recently, the James Webb Space Telescope has spotted ancient dwarf galaxies from that epoch. Turns out, they're the ones we should be thanking for lighting up the universe. Back then, they were filled with early stars. These stars emitted tons of radiation that was so powerful that it managed not to just overcome, but break apart the hydrogen atoms in the fog. It turned them into charged particles, like particles that carry a little bit of electricity called ions. Little by little, the fog was cleared away. This process of clearing out the fog is called reionization, and this beautiful time is known as the epoch of reionization. Finally, the light was able to travel to all corners of the universe, which was a game changer, just like humans' Age of Enlightenment. To find these little igniters, astronomers used a technique called gravitational lensing. Imagine light traveling through space like a straight beam. But just like everything in our world, even time, light obeys gravity. If it's too strong, it'll literally bend the light beams. So when the beams pass near a massive object, the object's gravity pulls on them, curling and twisting their path. That's why black holes look so creepy, as they stretch stars and space around them like some whirlpools. But it's not that creepy. A regular glass or magnifying glass does something similar, hence the name gravitational lensing. When the lensing object is horrifyingly massive, it bends the light into multiple images of the same object, creating a creepy and mesmerizing structure called an Einstein ring. But if it's not that big, then the bending is less dramatic, and it just slightly distorts the shape of the background object, making it look kinda stretched. Gravitational lensing also helps scientists study things like the spooky dark matter. If the light looks stretched, and it's not just because of some obvious massive objects nearby, then it might be something invisible and heavy bending it. Since these 8 galaxies were too faint, no wonder they're almost as old as my unread emails. Scientists had to use these gravity tricks to observe them. The team studied light from galaxies that are over 13 billion years old. Finally, they focused on a galaxy cluster called Abell 2744, also known as Pandora's Cluster. And these findings helped them understand how even little fellas played a huge role in transforming the early universe. The James Webb Telescope is an incredible tool, and soon it might help us look at even earlier times, at the cosmic dawn, when the universe was only several millions of years old. Another great tool, called the Roman Space Telescope, is going to help it. It's also possible that these galaxies weren't the only helpers in this entire saga. These early massive stars were absolutely terrifying. They just don't make them like that anymore. Some estimates suggest they were 30 to 300 times more massive than our Sun, and millions of times brighter. Modern stars have some heavier elements in them, but back then, they used only the stuff available, hydrogen and helium, which is why they were so hot and shiny. But they also had very short lifespans, lasting just a few million years. For example, our Sun is 4.6 billion years old and is still going strong, thankfully. At the end of their lives, they went supernova. These colorful bursts of energy were so strong that they forged the first heavier elements in our world and spread them across the universe, planting first seeds for the future planets. Meanwhile, the stars themselves didn't just disappear. They collapsed under their own gravity, creating the first black holes. Now, the black holes are also known for producing insane amounts of radiation, so it's possible that they might have helped speed up the clearing of the fog. Ironically, they help the universe shine brighter while sucking up the light at the same time. Recent discoveries show that black holes might be much older than we used to believe. They probably helped new stars and galaxies form. They were millions or even billions of times the mass of the Sun. The James Webb Telescope has already found a pair of early quasars. That's what we call the bright centers of galaxies powered by supermassive black holes. It's a curious pair of quasars that are merging just 900 million years after the Big Bang. This might be the earliest and most distant pair of merging quasars ever found. The telescope has also been studying things that are called cosmic lighthouses. In scientific language, they're pulsars. Pulsars are super-dense remnants of massive stars. They form from stars that were once 4 to 8 times more massive than our Sun. One of the greatest things about them is how fast they spin. They're one of the fastest objects in the universe. They might do around 700 rotations in just 1 second. They got their name because they behave like lighthouses, basically flickering radio waves. These beams of radiation sweep across the sky, creating a pulse-like signal that we detect. Now, a star basically works like this. There's nuclear fusion happening inside of its core. Atoms get fused in each other, move at crazy speeds, bump, all meanwhile releasing an unbelievable amount of energy. That's why they emit tons of light and heat. Of course, all this pressure tries to push outward, sweating like crazy to expand a star. The greatest the fusion is, the more powerful and insane the star gets. On the other hand, there's gravity that's pulling inward, trying to compress the star and keep it a nice small dense ball. As long as there's balance, the star keeps living, but when it gets old and spends all of its nuclear fuel, it becomes too weak to generate the energy it needs and can't fight against gravity anymore. That's when it basically collapses under its own weight, going supernova. What's left behind is the star's core, but now it's crushed down to an incredibly small size, about 12 to 17 miles across. It's roughly the size of a city. This dense core is known as a neutron star. The material in a neutron star is so dense that just a teaspoon of it would weigh as much as 4 billion tons, like 10,000 Empire State Buildings. And all this collapse sets off a trigger, causing the neutron star to spin super fast, creating a pulsar. It's kind of like when an ice skater spins faster when they pull their arms in. Pulsars often have a smaller star friend orbiting them, although it's not always a friendly relationship. Not long ago, astronomers discovered a pulsar that was surrounded by lots of energetic material for some reason. They realized that all this material was the remnants of another much larger star. Turns out, the pulsar had been slowly destroying its friend with its terrifying radiation and particles until it basically ate the neighbor away. It's similar to how a black widow spider consumes its mate. So, systems like this were called black widow pulsars. In any case, these lighthouses most likely help the reionization process as well. A long time ago, they could be very energetic stars in small galaxies and could emit enough radiation to transform the early universe. The James Webb Telescope's mission is to find more of these lighthouses and see what role they played in the universe's evolution. On July 23, 2024, Europe's Solar Orbiter spacecraft observed a super-powerful solar flare erupting from the far side of the Sun. This flare wasn't the most extreme ever recorded, but still, we got extremely lucky this time not to get fried by it. Such solar flares often cause long-lived, raging radiation storms, and if such a storm moves in the direction of Earth, it can lead to worldwide blackouts. Before we go deeper into details of that potentially disastrous solar flare, we need to figure out what exactly this solar phenomenon is. Solar flares occur because the magnetic fields in the atmosphere of our star are moving non-stop. When the Sun is approaching its solar maxima, and that's the most active period of its 11-year-long cycle, which is, by the way, exactly what's happening now, its magnetic fields get more and more tangled, making our star look like an enormous ball of tangled rubber bands. They loop around, cross over one another, cut one another off, and then reconnect. Ever seen iron filings sprinkled on a bar magnet? These filings line up along the magnetic lines of force. Like that, the hot plasma on the surface of the Sun is at the mercy of the magnetic lines of force. Sometimes, when the magnetic fields interact with each other, some plasma gets disconnected from the fields, and its particles accelerate to immense speeds and send powerful radiation to space. That's what a solar flare is. Other times, our star throws off massive amounts of matter. Those events are coronal mass ejections, CMEs. Just one CME can contain as much as 20 billion tons of material. If that material were rock, it would create a mountain about 2.75 miles across and almost a half a mile tall. The ejected material often travels at a speed of over 1 million miles per hour. Solar flares and CMEs are the most powerful explosions in the solar system, releasing unimaginable amounts of energy. Solar flares have their own classification according to their strength. The smallest and weakened ones are A and B class. Then there are C and M class solar flares, and the strongest are X class flares. A number from 1 to 9, and in some cases a larger one, accompanies each letter. That's similar to the Richter scale for earthquakes. A and B class flares are too weak to affect our planet. As for C class flares, they may have small, noticeable consequences. M class flares can cause short radio blackouts at the poles and weak radiation storms that can still harm astronauts. But the most dangerous of them all are X class flares. These are flares more than 10 times more powerful than X1. That's why the classification of X-class flares can go higher than 9. Now let's get back to that recent solar flare. It was X14 Class 1. Now, we already know that it means it was an extra strong flare. Other large flares astronomers have detected recently include an X12 solar flare that happened on the 20th of May and an X10 flare that occurred on the 17th of July. All of them have come from the backside of the Sun. If we talk of the Earth side of our star, the largest solar flare that has been recorded so far within this solar cycle happened on the 14th of May. It was an X8.7 flare that led to radio blackouts, and a strong geomagnetic storm leading to magnificent auroras all over the world occurred a few days earlier. Powerful coronal mass ejections accompanied this storm. As for the July X-class flare, it was so powerful that it could have ended up tragically for us. Luckily, all that magnetically charged plasma blast that accompanied the flare didn't travel in our direction. If it had, it would have been quite the solar storm. Auroras would have been incredibly impressive and a wee bit terrifying in their magnificence. But at the same time, such a dynamic blast of energetic particles hurtling our way could have caused major technological problems and electrical blackouts, like the event in 1989, which severely harmed Quebec's power grid, or a much earlier catastrophe that still managed to cause a lot of harm to the world. I'm talking about the Carrington event, which occurred in 1859 and was the first documented solar flare affecting our planet. It happened on the 1st of September and was named after Richard Carrington, the solar astronomer who witnessed the flare through his own telescope and sketched the sun's sunspots. According to scientists, that flare was the most powerful documented solar storm over the last 500 years. The Carrington event triggered auroras that were visible as far south as the Caribbean. It led to severe interruptions in telegraph services all over the world, even shocking some telegraph operators and sparking fires after discharges from the lines ignited telegraph paper. Another major solar flare that erupted on the 4th of August, 1972, destroyed long-distance phone communication across a few states, including Illinois. This event even made the American Telephone and Telegraph Company redesign its power system for transatlantic cables. Now let's move to March 1985, when two super-powerful CMEs triggered a geomagnetic storm, which, in turn, set off a power blackout in Canada on the 13th of March. This blackout left around 6 million people without electricity for 9 hours. It is said that the flare disrupted electric power transmission from the Hydro-Quebec generation station and melted a few power transformers in New Jersey. And still, this solar flare was nowhere near the power of the Carrington event. The Bastille Day solar storm took its name from the French national holiday because it occurred on the same day, on the 14th of July in the year 2000. It was an X5 class event that caused some satellites to short-circuit and resulted in radio blackouts. It's still one of the most highly observed solar storm events. From October to November 2003, our star unleashed a series of large solar flares and coronal mass ejections, and they did reach Earth and slam into our atmosphere. Those solar storms, also known as Halloween storms of 2003, caused aircraft to be rerouted, impacted satellite systems, and led to power outages in Sweden. Besides, the Solar and Heliospheric Observatory couldn't fulfill its functions during this solar onslaught. On the 28th of October 2003, the Sun sent a whopper of a solar flare our way. The fire was so powerful it overwhelmed the spacecraft sensor that was measuring it. The sensor topped out at a whopping X28. But later, scientists figure out that the flare had reached a peak strength of about X45. One more thing that made the Halloween storms so scary was that they happened during a time in the solar cycle when solar activity is usually quiet. That's 2 to 3 years after the solar maximum. According to NASA's statistics, just 17 powerful flares erupted from our star during that time. The Sun spewed out another X-class solar flare on the 5th of December 2006. It was an X9 class flare that disrupted satellite-to-ground communications and GPS navigational signals for around 10 minutes. That solar storm was so powerful it even damaged the Solar X-ray Imager instrument on the GOES-13 satellite. It sustained damage to several pixels of its detector. In February 2022, SpaceX experienced the terrifying power of our star when a devastating geomagnetic storm destroyed 38 Starlink satellites worth tens of millions of dollars. It happened shortly after they were deployed. Unfortunately, Starlink satellites are especially vulnerable to geomagnetic storms since they're released into extremely low-altitude orbits, between 60 and 120 miles. They also rely on their onboard engines to overcome the drag force and raise themselves to their final altitude of around 350 miles over the surface of our planet. The thing is, during a geomagnetic storm, Earth's atmosphere absorbs energy from the storm, heats up, and extends upwards. It results in a denser thermosphere, which means more drag, and it can be a serious issue for satellites. That's exactly what happened. The batch of newly released Starlink satellites didn't manage to overcome the increased drag and started to fall back, eventually burning up in the atmosphere. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future circular collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink, wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this great attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So, just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! the signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy 2 of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. Does the universe ring like a crystal glass? Maybe. But it doesn't mean that it literally rings and we just don't hear it. It just vibrates. Many of you know that the universe started with the Big Bang around 13.8 billion years ago. I wasn't around then, but we can assume. The whole enchilada was born from a super concentrated, hot, and dense tiny dot that contained everything. When it couldn't bear its pressure anymore, it made a huge blast and spewed around all the time, space, matter, and antimatter like a Pokeball. After being born, the universe moved at a breakneck speed. Imagine standing in the middle of nowhere, you blink, and suddenly you're surrounded by the universe. That's what it would feel like. It started growing and growing, and eventually, its speed got slowed down a bit by gravity. Gravity started pulling all the matter together, slowly helping new things like stars and galaxies to form. Okay, makes sense so far. The Big Bang gave the universe a big push, accelerating it. Logically, everything should eventually slow down and start moving at a constant speed, or even stop, right? Well, nope. In the late 90s, astronomers discovered something weird. They looked at some supernova around us, and for some reason, these supernovas were super far away, much farther than they were supposed to be. In other words, the expansion of the universe is not only continuing after all these years, but it's even accelerating. After years of study, they discovered the concept of dark energy, a mysterious force that makes up about 68% of the universe's total energy. This energy pushes it to expand even faster over time. And now, scientists have proposed a new discovery. Perhaps the universe's movements are a bit, well, wobbly. It seems like the universe's expansion hasn't been smooth and stable over the years. Instead, it has undergone periods of speeding up and slowing down multiple times. Astronomers counted about 7 cycles of this acceleration and deceleration over the history of our universe. This can be compared to the oscillation of a crystal glass. When you strike a crystal glass, it vibrates, oscillating at its natural frequency. It goes through fluctuations in which the frequency rises and falls. Over time, it calms down and fades away. Well, something like this is happening to our universe. You can imagine its speed also fluctuating like that, rising and falling, first super rapidly and then more calmly. As if it's not just different waves traveling through it, but our entire world is like one huge ringing wave. The discovery was actually made by accident. Astronomers were working on dark matter modeling. They plotted a new graph called the Hubble diagram, which shows how big the universe got over the years, measured in supernovas. Supernovas are like some lighthouses of our world, helping us mark things on a map. That's when they found these oscillations. But we still need to check all the data to make sure that this discovery is indeed true. Dark energy and dark matter play this weird game with the universe, where one is constantly trying to pull everything together, while the other one wants everything to expand. So far, dark energy vastly outweighs dark matter, whose weight makes up only 27% of the universe. Now, both of them are invisible to us. And not just invisible to our eyes like infrared, it's that we literally can't detect them in any way. We can only assume that they exist based on how they influence gravity, changing entire galaxies, and all the large-scale structures of the universe. We basically made them up because it was the only way to explain how our world works. Dark energy is uniformly distributed across space and time, and we're still not sure what exactly it is. Some theories say that it could be a property of space itself, quantum fluctuations, or even a new type of field or particle. But all we have for now is an invisible energy that pushes the universe to move very fast. If one day we learn more about it, this will help us predict the entire fate of our world. Depending on how exactly dark energy works, the universe may continue expanding and growing indefinitely, or maybe one day it will experience the Big Rip, where all matter will be completely torn apart. Okay, here's to hoping we're not all around for that. Meanwhile, dark matter, also invisible and yet to be proved, works the opposite way. It's not energy that accelerates things. Instead, it's more like a glue that tries to hold everything together. It's a type of matter we can't detect because it doesn't emit, absorb, or reflect light. We don't even know what particles make up this thing. We still can't catch them. At first, we thought it might be made up of regular heavy particles, like the one that makes up our world. But after years of research, they haven't found even a single one. So now they think maybe it's actually made up of ultralight particles, millions of times lighter than anything we know. And because of that, we can't even notice them properly. So now, astronomers try to detect not the particles themselves, but waves that they could leave as they move through space. But we believe that it exists, because if it didn't, our galaxies wouldn't hold together. Dark matter helps them form, grow, and rotate. So, about 85% of our world is made of something unknown. All of this is incredibly mysterious and needs a lot of research. But that's what we know now. Maybe in the future, we'll discover something that will completely change our perception of the universe. That's what happened to Albert Einstein. In the early 20th century, most scientists, including Einstein, believed that the universe doesn't actually move. They thought it was static, neither expanding nor contracting. That's because, to us, it feels like it doesn't really move. Back then, scientists didn't have powerful computers or telescopes that could detect all the little changes in the positions of stars and supernovas. When Einstein developed his famous general theory of relativity in 1915, his equations actually suggested that the universe should either be expanding or contracting. This didn't really make sense to him. To fix this calculation flaw, he decided to introduce a new term, the cosmological constant. It was like a repulsive force that counteracted the attractive force of gravity. Essentially, it meant that while gravity tries to push everything together, some force or energy helps to balance this out by pushing everything apart. Sounds familiar? Then, in the 1920s, astronomers Edwin Hubble and Georges Lemaitre found out that the universe isn't static, it actually expands. They noticed a slight reddish tint from the distant galaxies, and this tiny hint meant that other galaxies were moving away from us. After that, Einstein scratched out the cosmological constant. Interesting how he was later ashamed of this assumption, calling it his greatest blunder. He didn't even know that he was 100 years ahead of his time, accidentally discovering dark energy. Now the cosmological constant is back again, just in a new form. Something similar happened with dark matter. Scientists have already started noticing that something doesn't add up back in the early 20th century. They saw that galaxy clusters didn't have enough visible mass to hold them together, which means there must be some unseen mass that helps to make up for it. And that's when it got its name, the dark matter. This stayed unresolved and unproven for many years. And then it was finally discovered by Vera Rubin when she was observing galaxies and their movement. She realized that outward parts of galaxies move almost as fast as their central parts. This doesn't really make sense. The outer part should be a bit slower. This became the first official proof of dark matter, which boosted its research. There are still many things left to be discovered. But maybe one day, we'll understand what is this invisible part of our universe that makes it ring.
Is there a giant mega-sun in the center of our Milky Way? Scientists actually thought so for a while because it's the brightest place in the galaxy. It has millions of stars packed into a small area. This area is called the gigantic bulge. The gigantic bulge has millions more stars per light year than any other part of the galaxy. It can be 10 million times denser than our part of the neighborhood. In some cases, stars in this region are only 5 light days apart. That's like if there was another star in our solar system a bit further away than Pluto on a space scale. But why is this place so dense? When galaxies form, a lot of gas and dust come together under the force of gravity. This material gathers up and eventually forms stars. Gravity and angular momentum balance out, and it starts looking like a flat disk with a pretty bright, bulging, dense core. The stars live their comfy lives, and once they get to the finishing line, they collapse under their own huge weight. Then, the black hole forms. Black holes love to eat everything around them, and the more they eat, the bigger they get. And what place is more perfect for a fine dinner than the galaxy center, where all the space stuff is packed together? So it starts eating surrounding gas and dust, forming an accretion disk. As this material spirals into the black hole, it heats up and emits a lot of energy, which makes the center of the galaxy even brighter. That's why you can find both supermassive black holes and galactic bulges in the centers of all galaxies. The galactic bulge at the center of the Milky Way looks a bit like an ellipse. That's a classical bulge. Stars aren't like our sun. They move randomly in all possible directions and planes. Plus, they all move at different speeds. So gravity is going crazy there, and this makes the bulge look more like a sphere, or an ellipse. Since they were the first ones to form, they have some of the most ancient stars in our galaxy. But there are also some places of star formations and lots of younger, massive stars that are less than 100 million years old. As we move farther away from the center, things get a bit calmer. Stars start rotating uniformly and become stable. Right now, Earth is in one of the Milky Way's spiral arms called the Orion Arm, pretty far away from the galactic bulge. In our part of the neighborhood, stars are usually about 4 or 5 light years apart. This means that most of a galaxy is actually just black, empty space. Our black hole is called Sagittarius A star. It's a monster about 4 million times the mass of our Sun. It's also about 32 million miles in size, almost like the distance between Mercury and the Sun. But don't worry, it's not attracting the Milky Way inside it, and it's not going to eat us. These black holes are actually super small compared to the entire galaxy, so they can only eat whatever's around. Right now, many stars orbit Sagittarius A star, and even though it emits a huge amount of energy, we can't see its light from Earth without a lot of scientific effort. But why don't we see the center itself? The galactic bulge is so bright that even though it's 26,000 light-years away, we should see it shining brightly in our sky. Yet, we don't. Turns out it's all because of space dust. There's a lot of dust between us and the core, and it absorbs most of the visible light. We can only look at the galactic core using other types of light, like near-infrared, gamma ray, and so on. NASA has images of the core in different types of light, and it shows how scarily bright the center is without the dust blocking our view. But not all bright regions are blocked by gas and dust. For example, when we look at dense clusters like the Messier 13, the stars are so close together that they look just like a white spot. Most of our telescopes can't separate them from each other. The satellite galaxy M32, our neighbor near the Andromeda galaxy, has about 84 stars per light year. It's so dense that stars can't be resolved even by the Hubble Space Telescope. To get the idea, our solar system is 2 light years long. We'd see about 168 stars outside our window if we were there. Our closest star is Alpha Centauri. It's about 4 light years away from the Sun. If it was just a couple of light days away, it would shine much brighter than the full moon. So if we somehow managed to survive in crazily dense star regions, the sky would be white all day long. But it's unlikely that we'd make it. As we get closer to the center of the Milky Way, the chances of finding life get super slim. The gravity of stars is going wild with chaotic movements, so there are barely any planets around. On those miracle planets, the radiation from cosmic rays is skyrocketing. Supernova blasts and star collisions nearby become an everyday occasion, and all the gas around makes it basically impossible to breathe or even see properly. At the same time, as we move further away, there are fewer stars around. Elements that are super useful for life, like carbon, oxygen, and iron, are produced by stars, so they also drop. Too much radiation is awful, but too low radiation means that there's not enough energy to support chemical reactions, like photosynthesis. Which is why, if there is extraterrestrial life, it would most likely be somewhere in the middle of different galaxies. But some galaxies get their brightness from a so-called active galactic nucleus. These are extremely energetic regions at the center of some galaxies. They shine much brighter than any stars imaginable, although it mostly shines only in certain parts of the electromagnetic spectrum. The brightness comes not from the stars, but from the accretion disk around their supermassive black holes. As the material slowly falls into a black hole, it gathers around it and creates this flat, spinning disk of gas, dust, and other stuff. Since the gravity and friction there are insane, this disk heats up and starts emitting enormous amounts of energy. Also, this disk spins incredibly fast, almost at the speed of light. Because of that, collisions there happen all the time, and they're unimaginably powerful. They release even bigger amounts of energy. Most galaxies don't have an AGN. Those that do, like the galaxy M87 in the Virgo constellation, are called active galaxies. There are also different types of AGNs. The Seyfert galaxies, radio galaxies, and finally, the winners of our space brightness competition, quasars. Imagine things so bright that they can outshine the entire galaxy they belong to. Quasars are a specific type of active galactic nucleus, the most extreme and luminous form. They belong to the supermassive black holes, the biggest ones in our universe. Quasars are like a combination of several things. First, they're the brightest accretion disks in our world, because of their behemoth black holes eating everything around. But they have some cool features. For example, they have powerful jets of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets add up to the brightness of the quasar, although they can only be seen in radio wavelengths. The energy they emit is so intense that they can be seen billions of light years away. However, the nearest quasar to us is 600 million light years away, so we can't see them with backyard telescopes. So, when we look at a galaxy through a telescope, we usually see only the brighter core, not the outer parts. Unfortunately, our eyes just aren't made to see things like the active galactic nucleus. So, these stars are the brightest things we can see. But what a beautiful sight it is. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the Europeans that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal poor star. It suggests that the star that collapsed and formed BH3 was metal poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Matola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravistar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravistar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravistar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravistar or a traditional black hole.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide, or simply DMS, in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean, with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini-Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from two of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheroidal beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles, the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time.
Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus, since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But Vasco is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
So this year, before September, a star in the constellation of Corona Borealis will explode, and in the Northern Hemisphere, we'll be able to see it with the unaided eye. The star is T Corona Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event, if you're human. T Corona Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two. But the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. Just like golf, low scores, you know. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now, we can only see the binary with binoculars in a completely dark sky. After the outburst, T Corona Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Corona Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Corona Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September this year. The constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arcturus, finding the bright star in the Buddhist constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis. Now, if you want to observe the brightening of T Corona Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, a nova is a short-lived sudden explosion involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 nova happen every year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several nova that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves, racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where 2 stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another, or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days or even months. Supernovae aren't common. Astronomers think just a few of them occur within the century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time.
Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or a GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how big or bright it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories have been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis Earth spins around and extended it over 300 light-years past the North Pole, at the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point towards the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the fifth brightest star in the night sky and the second brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it'll regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old star system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 15-inch refractor, and it happened again in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution.
you're one of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one of almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe. That itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely, there must be some other habitable planet. Here's where the Fermi paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allow scientists to discover over 5,000 planets outside our solar system. Yet, still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi paradox. These outer world beings may be just too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rocket would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. Now, we could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet, not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for someone else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope. And this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet. The same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant in a hibernation status. And they might be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form. But those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution. And this may be a potential future for us, too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. Well, if it can happen to us, who's to say it didn't happen to other species in the past, on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe, forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi paradox has a name, though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide-and-seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, Destroying them first could be our only hope. So if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups became friends, but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivete. The dark force theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claim the news is fake, others try to understand the reality that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light-years of us might be getting our signals, and if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water there is no life, at least not as we know it. So, it begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe – carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think – Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model.
Chebysky's star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chebysky's star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien technosignature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chebysky's star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chebysky's star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf-Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova. But this time, the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that 2 stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf Rayet to produce a gamma ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only a third the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate, and then scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. But the dark halo around its middle is a telltale sign of Vega's oblate shape.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them. There might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought.